सब्सक्राइब करो ये चैनल को नोटिफिकेशन रंग होमन सोनाक द बेल आइकन को क्लिक करो Number 19. A box contains 20 cards numbered from 1 to 20. A card is drawn at random from the box. Find the probability that the number on the drawn card is A divisible by 2 or 3, B a prime number. Ino daganya kisa box o 20 cards dunga. Dimna 20 cards o number onko siya dunga 1, 2, 3 up to 20 ona kangkang. Dimna card ko bungbang jebasini kolchip pa hana box oni ko. Dimna J card ko na box oni ko round katacham uni probability ko amnagda nangen. Dode J card ko na round katacham wera divisible by 2 paung jode divisible by 3 ungna nangen. Niman probability of getting a card divisible by 2 or 3 because kanga bam ching nangen ini jamode probability of getting a prime number ko amnagda nangen. Skanga bao total number of cards ne here total number of cards is equal to inon jana paha 20 cards in even total number of cards de 20. So let's kang about number 8 can solve again. The game na number divisible by 2 or 3 kas kang ba am ching nangen. Numbers divisible by 2 or 3 are skang bao dore number rang 2 bong jore 3 kigini uni gisachi divide kana mangpa ungna nangen 1 kode 2 chi ba 3 chi divide kana manja 2 kode 2 chi divide kana mana ini gamis kang bode 2 devna gini bode 3 minus 3 kode 3 chi divide kana mana ini ja ode 4 ko ba 2 chi divide kana ini man 4 5 kode 2 chi ba 3 chi ba divide kana manja deba 6 kode 2 chi ba 3 chi ba mana ini gaman 6 7 kode manjawa 8 ko 2 or 3 8 ko 3 chi manja deba 2 chi mana ini gaman 8 digamang 9 ko 3 chi mana digamang 10 ko 2 chi mana 11 ko de manja digamang 12 ko de 3 chi ba 2 chi ba mana digamang 13 ko de manja digamang 14 ko 2 chi mana 15 ko 3 chi divide kana mana digamang 16 ko 2 chi mana 17 ko de manjawa digamang 18 ko 2 chi mana 19 ko de manjawa 20 ko 2 chi divide kana mana. So the number of favorable outcomes ko nangen. Therefore number of favorable outcomes nade numbers divisible by 2 or 3 ko channa nangen chanbo 1 2 3 4 5 6 7 8 9 10 11 12 13 nunga. So the probability of number divisible by 2 or 3 ne probability of number divisible by 2 or 3. So the probability ni formula rong jok number of favorable outcomes divided by total possible outcomes. So the number of favorable outcomes de 13 divided by total possible outcomes de and total number of cards anungya total number of cards de 20. Iniman probability of number divisible by 2 or 3 is equal to 13 by 20 and number any answer. Number B de number B niko probability of prime number ko amnagda nangen. Here prime numbers are Tode number ang ron sujok question 1 to 20. Tode 1 uni 20 una mai me number ang prime number uko list kaching na nanggen. Tode prime number tode macro prime number mga je number angon factor gi ignition donga je kai number antang aro 1 je kai 2 ni factor ang ba 2 aro 1 san donga 3 ungin simo de 3 ni factor ang ba 3 aro 1 san donga temna 4 ni factor ang de 4 antang donga 1 donga aro 2 ba donga ire factor gi tham ong jok ini man 4 ko de prime number chanja temna 5 pan prime number onga mana 5 pa 5 antang aro 1 san donga wandeke tore skang ba prime number de 2 1 dong ja mana 1 ode factor gi sasan donga ini man 1 ko de prime number chanja ini man skang ba prime number de 2 ni sabasinga ini jong ode 3 4 dong ja digam na 5 6 dong ja digam 7 8 bong ja 9 bong ja 10 bong ja 11 12 dong ja ini sama de 13 14 dong ja 15 bong ja 16 bong ja digam 17 digam 18 bong ja and 19 yan bon kham ba 19 ini sama de 20 the prime number jok the number of variable outcomes, so therefore number of variable outcomes equal to the prime number sangko chan bojok 1 2 3 4 5 6 7 8 number of variable outcomes de 8 ini man probability of getting a prime number. The probability of getting a prime number again the number of variable outcomes day 8 divided by the total possible outcomes day and total number of cards 20. The 8 by 20 go cancel again. The 4 cancel ko the 48 or the 2 times the 20 or 5 times, so this is equal to 2 by 5. Yes sir, probability of getting a prime number. Number 20. Using Euclid's division algorithm, find the HCF of 9367 and 3451. Euclid's division algorithm ko jakalimana ye number gi ignini HCF ko amnagdan anggen. Kramai ki solve kagena ye number dalbat ba ko ye number chunbat ka bachi divide kana anggen long division method ko jakali ni jangade Euclid's division algorithm ko jakalimana iko solve kagen 3 4 5 1 9 3 6 7 you can divide again the 3 4 5 1 into 2 again into 2 again small de better gapna 6902 ne 6902 the 7 minus 2 de 5 the 6 minus 0 de 6 the 13 oni 9 yang de 4 you know the 7 minus 6 oh sorry you know the 8 no 8 minus 6 2 8 minus 6 2 2465 now the remainder 0 umkuja ni man remainder 0 umkuja to pette ko de continue kar kar again digam ne ya remainder chi ye divisor ne ye remainder chi divisor ko divide again the divisor de 3 4 5 1 demna 2465 into 2 de man join man 2465 into 1 again small de 2465 demna subtract out de 11 minus 5 to 6 demna no de 4 dong kya 14 minus 6 again small de better kya 448 demna no de 3 inoni ko na de 13 minus 4 de 986 so the 986 here 2465 could divide again 2465 so the 986 into 2 times on there 1972 yeah then 5 minus 2 to 3 the among you know there you know equal around 16 minus 7 there but on yeah 16 minus 7 9 Tigamang yun ko one rang ode inode betong ngok 13 minus 9 ka ode 4 sorry 4 ne 4 493 da ode 493 से 986 को divide again so the 493 into 2 again semua ode 986 dimana 6 minus 6 0 inove 0 0 mana de 96 minus 96 is 0 Today Euclid's division algorithm has again 9367 Yerongjok dividend. So dividend is equal to divisor into quotient plus remainder. Today dividend is equal to divisor the 3451 into quotient the 2 plus remainder the 2465. Dimana ya second line ne first gaba line de masuk the second line the dividend de 3451 is equal to divisor the 2465 into quotient de 1 plus remainder de 986. Then ya second line de masuk the third line third line de dividend de 2465 is equal to divisor de 986 into quotient de 2 plus remainder de 493. Dari third line de masuk de last couple line de dividend de 986 is equal to divisor de 493 into quotient de 2 plus remainder de 0. So the solo remainder 0 aha inode ikuba stop kaijok khangna nangjaha ini mana second since remainder is equal to 0 so therefore HCF of 9367 and 3451 is equal to betana then last kaba divisor ne last kaba divisor and 1 HCF nya ini man last kaba divisor de 493 yes HCF of 9367 and 3451. Number 21. Find the sum of the following series 72 plus 70 plus 68 plus it goes on up to plus 40. Inode onsoguman series ni sum khomna nangen tode sum kode make denote kana SN ni denote karunga inode SN ni formula gegini dunga SN equal to n by 2 into a plus l gesera n by 2 into 2a plus n minus 1 into d वो formula gini runga dar badek bo formula ko jakhagen kora make masigina inode first term kon swaha aro last term ko bon swaha ini man last term dong pa ode last term kon swaha ni man inode sn is equal to sn is equal to n by 2 into a plus l ya formula ko ino jakhalgen mane no last term ko mashiani man kora make answer hagena skang bao first term aro common difference ko find out again so here a mane the n first term so a is equal to 72 oh sorry 72 ne 27 ongja 72 so a is equal to 72 and d is equal to second term minus first term in human 70 minus 72 which is equal to minus 2. So we know that L is equal to a plus n minus 1 into d. Here formula ko again. I know last term ko masya. Tawde last term ko masya ni mana ya last term ni formula L is equal to a plus n minus 1 into d. Ya for formula ko sakale mana ya n beta ko calculate again. A ko masya, d ko masya, aro L ko masya. Tawde n ko calculate again. So this implies L arong jok 40. You know non so ha. So this is equal to a de 72 plus n minus 1 into d de minus 2. Then now 40 left side to 72 ko left side on about minus 72 which is equal to the dikho multiply how de minus into plus de minus de 2 into n de 2n minus into minus de plus 2 ones are 2. So this implies it betong unok dalbat ka number minus sigma 2 minus 0 de 2 7 only 4 yang ode 3 de 2 ko shift ka ode minus 2 which is equal to minus 2n. And this implies that the minus 2n ko left side of second even yaho right side of second jmo de betong unok minus 34. So this implies that the left side to be negative, right side to be negative, in the negative negative cancel. Digamna and could unropo digamang 34 digamang 2 come achieve again. So 34 by 2. It positive one minus in the negative negative cancel on majok. So n is equal to 34 by 2. That 34 ko 2 should divide ka betong 17. So I got n is equal to 17. Jadi Sn ko calculate ka naman again. So Sn is equal to the siyang yakan pa formula n by 2 into a plus l, n by 2 into a plus l, and this implies Sn ko de masyang 17 in S17 is equal to, and the 17 divided by 2 into a de betana 72. So 72 plus l de then also have 40. So this is equal to 17 by 2 into 2 plus 0 de 2 7 plus 4 de 11 de 2 ara 112 pora betan apinga 2 ara 11 de 5 times de 2 5 is 10 11 minus 10 de 1 2 around de 12 2 6 are 12 de 17 into 56 kabo betegaknya 56 into 17 kagis mo de 7 6 are 42 carry over 4 de 7 into 5 35 35 plus 4 de padong unok 39 dimna 1 into 66 1 5 is a 5 dimna 2 9 plus 6 de 15 carry over 1 dimna 3 plus 1 de 4 4 plus 5 de 9. So 952. Yes sir, answer.